Hello, let's get into real-world inequalities. Real-world variables and inequalities. Graph each inequality from the given description. Please pause the video at any time to write down problems, copy graphs, and work on the problems on your own. Resume the video when ready. Let's look at the first one. T is non-negative. That means T cannot be any negative number on the number line. Okay, so that means we can start at 0 because 0 is not negative, nor is it positive. So T will be greater than or equal to 0. So that's a close circle, shade to the right. X is positive. That means X can be any positive number. Now this is a little different. We're still going to start at 0, but this time X is greater than 0. So we're going to do an open circle, arrow to the right. K is no more than 3. This one actually means the opposite when you're dealing with inequalities. So K can be any number lower than 3. So that's going to be K is less than 3. So that's an open circle at 3, shade to the left. R is at least 2. This means R can be exactly 2 or more. Remember, with inequalities, these phrases mean the opposite. So instead of at least, which would make you think less than, it's actually going to be greater than or equal to 2. So that is a shaded circle at 2, arrow to the right. V is no less than 7. This is actually similar to our previous problem. V can be exactly 7 or more. So that's two different phrases to say the exact same symbol, which is V greater than or equal to 7. Close circle at 7, shade to the right. You might have to redo these and look at it again, but you'll see it in the problems. Read the problem, write an inequality to model, and then solve the following problems. In this problem, let's define what our variable is. How many blankets the team must donate on Friday to make or exceed their goal. Okay, so let's let X represent the number of blankets to donate Friday to meet or exceed our goal. Well, what's our goal? At least 160 blankets. What does at least mean again? Yes, greater than or equal to. So at the minimum, we need 160 blankets, but this is a donation. We could always exceed our goal. So let's see if we can write out an inequality for this based on what we were given. We did some blankets. We donated some blankets on Monday. We donated blankets on Wednesday. We're going to donate some blankets on Friday, all just to get at least 160 blankets. So it should look like this. 42 plus 65 plus X is greater than or equal to 160. All right. And so remember, these numbers represent the days of the week, Monday, Wednesday, and Friday, plus our goal, the 160. So let's combine like terms. Subtract 107 from both sides. And we see that we need, by Friday, we need to donate at least 53 or more blankets in order to meet or exceed our goal. Not bad. Let's look at the next one. So we have your brother. He saved up some money for a vacation. He just bought an airplane ticket, and we need to figure out how much can he spend for everything else. Well, there's our variable. Let X represent the amount left to spend for everything else. All right. So can he spend more than $2,000? Nope. $2,000 is our limit. He can spend any amount of money up to that amount. So then therefore the 2,000 it's going to be less than or equal to for our inequality here. So we've already spent money on the plane ticket and we need to know what else we have left. So that's going to be x plus 637 less than or equal to $2,000. Let's subtract 637 from the 2,000, and that leaves us with $1,363 left in order to spend for everything else we need. I want to go on a vacation. Let's read these problems. Remember, you can pause the video at any given time so that I don't jump ahead of you. So we have the school club, it's Bicycle Safety Day, and each member is encouraged to sell at least 50 reflectors. So Monday we sold 17, Tuesday we did 12. How many reflectors do we need to sell on Wednesday to meet our goal? All right, well there's our variable. Let R represent the amount of reflectors that we need to sell Wednesday to meet our goal. And what's our goal? At least 50. So similar to the previous problem with the blankets, we have the blankets that we sold on Monday, Tuesday, and we're going to sell on Wednesday, but we need to add all this up and figure it out so we know how much we need to give by Wednesday. So combine like terms, subtract 29 from both sides, and by Wednesday, we need to at least have 21 blankets or more to meet our goal. Let's see what the science club is doing. They got a car wash. It's $4.50 per car. All right. How many cars do they have to wash to earn at least $300? Apologies for the typo there. So let's see. Let C represent the number of cars to wash to meet the goal. Okay. So that should be easy. It's $4.50 per car. So that's per C. And we have to earn at least $300. Remember, it's opposites, so that means greater than or equal to 300. Well, it's short enough of a problem. Let's just divide 4.5 under 300, and we get 67. There is no money sign in front of 67 because this is counting for cars. So these are whole numbers, right? But if you actually did the math, 300 divided by 4.5 is actually 66.67. It's a decimal number, but cars are counted in whole numbers, not decimal. So therefore, I actually rounded up to the nearest whole number for my final answer. You can check me, but if you put the cars at just 66, you'll be short of your goal. You have to round up in order to meet the goal of at least $300. Try these on your own. Pause the video, read the problems, work it out, resume when you're ready to check. So we're on a trip from Virginia to Florida, with the good old Sampson family. And they want to travel at least 420 miles in 8 hours of driving. What must be their average rate of speed? Okay, well, there's our variable. R represents the average rate of speed. Do you remember how to calculate speed? So let's see, I think it's this weird triangle where distance is on top divided by the time. And we have at least 420 miles, so there's our inequality. So S is greater than or equal to 420 miles in over 8 hours. So let's just divide. So our speed would be 52.5 miles per hour. It has to be greater than or equal to 52.5 miles per hour. All right, let's move on to the next problem. We have a rectangle, and we're going to let W be width and L be length. All right. So I like pictures. But here's a rectangle. And let's see, the length of the rectangle is 6 inches more than the width. Okay, so the length part is definitely not any inequality, even though you see more than. This is actually an equation. The length is width plus 6. Okay. The perimeter of a rectangle can be no more than 48 inches. That is definitely going to be our inequality right there. No more than 48 inches. Remember, the words mean opposite here in inequalities. So this is actually less than or equal to 48. All right, there's our perimeter formula with less than or equal to 48. But now we need to substitute. So I'm going to take that W plus 6 and throw it in there for the L. Boom. Let's do some distributive property magic. Combine like terms. Subtract 12 from both sides. And lastly, divide by 4 on both sides. So our width has to be less than or equal to 9. Okay. Again, try these on your own. Pause the video, resume when you're ready to check. So we have this pipe, right? And this pipe is at least 21 feet long. All right. And you want to cut it into 3 pieces. But let's let P represent the first pipe piece, okay? So if we cut it up, the first pipe piece to the left is just going to be P. It says the second piece is twice as long as the first piece, so that means 2P. And the third is to be 1 foot longer than the second piece. So remember, the second piece is 2P plus 1 more foot should be 2P plus 1. All right. So remember, this is at least 21 feet long. That actually means the opposite. It's not less than, it's going to be a greater than or equal to. And I put some pluses in between all my pipe pieces. Let's go ahead and do some combine like terms. Subtract the 1 from both sides and divide both sides by 5. So the first pipe piece has to be greater than or equal to 4. Let's look at the last one. So we're running a concession stand and a person gives you $18 and asks for 6 soft drinks, which are $1 a piece, and wants to know how many hot dogs can they get with the remaining money that they have to buy. And the hot dogs are $1.75 per person. All right. So first off, D represents the number of hot dogs. Let's write out what we already know. So you have $18, so that's a limit. You can't spend more than 18, so that's going to be less than or equal to $18. We have 6 drinks already bought, so that's 6 times 1, and then the hot dogs are $1.75 per dog. So that's $1.75 times D plus the $6 for the drinks, less than or equal to $18. Okay, so let's subtract 6 from both sides. And then we're going to divide on the side 1.75 under 12. So we get dogs, or we're going to get 6 or less dogs is how much we can do. So a maximum of 6 dogs is how many we can purchase. Now when you actually do the math for this, 12 divided by 1.75 equals 6.85. It's a decimal number, but hot dogs are counted as whole numbers, right? Not decimal. Therefore, for this problem, because this is less than, this is much different than that previous problem, I rounded down to the nearest whole number for my final answer. If you do 7 dogs, you won't have enough money plus the $6 for your drinks. You won't have enough money. You can work this out on your own to just prove a point. Hope you learned something. Thank you for watching.